speech scientists, and welcome to our presentation on Zemlin's parameters of normal voice quality. My name is Carrie Doppler, and I'm doing this assignment with Abby LeClaire. So in the following slides, we will discuss the 6 parameters that clearly demonstrate the multidimensional nature of voice quality and the interdependence of fundamental frequency, intensity, and quality. We will start with the maximum frequency range. This is measuring the normal voice and its flexibility and pitch during conversation. For this, we just measured a sample of normal conversation. For adults, you can measure this between, the measurement should be between 2.5 and 3 octaves for normal speech. Speech that lacks flexibility does sound very monotone, so we try to avoid that. Normal conversation has nice prosody and intonation to keep the listener engaged. As you can see here, my minimum pitch was 74.9 with a maximum of 321.107. This is the spectrogram, and yes, this was within normal range, between 2 1/2 to 3 octaves. Next, we have the speaking fundamental frequency. So this measures the average rate of vocal fold vibration during conversation. Children, this should be about 300 hertz, adult females 200, adult males 100. For this, we measured just a sample of conversation, shorter than the previous one. My median pitch during this conversation was 200 hertz. As you can see, it does vary in intonation and prosody throughout the graph. Next, we have the maximum phonation time. So this is the longest period of time an individual can sustain a vowel in one breath. For children, this should be at least 10 seconds. For adults, it's typically between 15 and 25 seconds. For this measure, we did a sustained ah vowel. As you can see, the phonation time was 22.15 seconds for this vowel. It did start stronger and then got progressively weaker as time went on. Nonetheless, it was sustained for the normal range. Moving on, we have the minimum and maximum intensity. So in this, we just measure the ability to vary your amplitude level by a minimum of 20 to 30 decibels. Healthy speakers should be able to do this. A person who does not may sound monotone. So once again, this was just with the ah sustentation. Minimum was 59.7, while the maximum was 75.9. There is a difference of 16.16, which is below average, but hey, that's okay. So next we have the periodicity of vibration. This is reflected acoustically as jitter. Jitter less than 1% is normal. Vocal fold vibration that is excessively aperiodic is often perceived as rough or hoarse sounding. Once again, we did this by measuring a sustained A sound. As you can see here, my jitter measurement was 0.44, so that is below the average of 1%. It is further demonstrated here using Pratt. I should mention that we use Pratt to do this whole assignment. You are able to show your results, monitor your results, and graph them, as we've been able to see with the spectrogram and the tables. Next, we have the noise generated by turbulent airflow. So this happens when a random distribution of acoustic energy can cause turbulent airflow, or when an obstacle interferes with vocal fold vibration. Like what we mentioned, the periodicity of sound should be nice and musical. When it is not, it is aperiodic, rough, and hoarse. So this was a sustained ah vowel with some roughness added to it for that horsey quality. You can see the mean to noise harmonics ratio of 0.127. This indicates noise. Well, we hope that you've enjoyed this presentation about the parameters of normal voice quality using Pratt and Screen-o-matic. Thank you so much for your time.